Welcome to my YouTube channel. Okay, we'll be talking about orthogonality. We're talking about orthogonality. Now, what is the meaning of orthogonality, and or what does it mean to say that two functions are orthogonal? So now, let R be a positive function on the interval, and x is defined on the interval of a comma b, the closed interval of a comma b of the real line. Then first, two functions f and g are said to be orthogonal with respect to the weight function r. So this r, that is a positive function, it is called a weight function in this place. On the interval, with respect to the weight function on the interval a comma b also, if and only if this condition is satisfied, that is the integral from a to b of f of x, g of x, and r of x. So r of x is the weight function with respect to x is equal to 0. So as long as this integral is equal to 0, we say that f and g are what? They are orthogonal to themselves. 2. An infinite set of functions. So it's possible for me to have a set of functions. This set could have infinite functions in it as its members. So you see, when n is equals to 1, 2, all the way to infinity, so you can have phi of 1, phi of 2, phi of 3, depending on what n assumes. So that is why it is called a set of functions. Defined on the interval a comma b is said to be an orthogonal system. So the thing is, there are two words here. One is orthogonal, the other one is orthogonal system. So the orthogonal is used when you have just two functions, but the orthogonal system is used when you have a set of functions. So it's said to be an orthogonal system with respect to the weight function r on the interval a comma b if for every two distinct functions of the set are what? Orthogonal with respect to r on this interval. So if I want to show that a given set of functions is orthogonal, then I have to pick two distinct functions that are different, they are not the same. Okay, so if you can get two distinct functions like phi of 1 and phi of 2, different functions, then that is, so if you can get two distinct functions and then you show that those two distinct functions with respect to the weight function is 0, then it is orthogonal. So another way of saying this another way of defining this mathematically is to say that this set is orthogonal with respect to the weight function on this interval if the integral from a to b of phi of n, phi of m, r of x ds is equal to 0 for every m. This is for every m that is not equals to n. So these are distinct functions. So your phi of n and phi of m, they are arbitrary functions from this set. You understand? So they are arbitrary functions from this set, and then they pick them and shows that they are orthogonal, and it's enough to show that this function forms an orthogonal system. So let's do an example to illustrate or to show how functions are orthogonal. So the first example, so it says the function sin x and cos x are orthogonal with respect to the weight function r of x equals to 1, that is the weight function on this interval 0 to pi. So that means your a, from definition, the x is on interval of a to b, so it means your a is now 0 and then your b is pi. So this function is orthogonal. They are telling us it is orthogonal. And how do we show that it is orthogonal? How do we verify that okay, it is true? So this is what you do. We do what? We consider this sin x then cos x. So we are going to integrate it with respect to x from 0 to pi now. Then the weight function is 1. The formula say, okay, let's follow the formula. So we have sine x first, then cos x. So times the weight function, which is 1, is provided, and then you have dx. So if you multiply that by 1, you obviously get the same thing. So let me just rewrite that. You get this ds. Okay, now how do you evaluate this integral? You can use the property of a trig. There is this formula from trig. This formula says sine 2x is equals to 2 sine s cos x. So what we are trying to evaluate here is sine s cos x. So if you make sine s cos x out of formula here, what do you get? Divide through by 2, you get sine 2x over 2. So you are going to insert this into the integral. So you have integral from 0 to pi of sine x cos x dx. So it will now be equals to sine 2x over 2. So this is very easy to integrate. So you can bring out your 1 over 2. You have 0 to pi, then sine 2x dx. So if you integrate sine, what do you get? You get cos. You get minus cos 2x over 2 from 0 to pi. So you add your limits. Okay, so now if you use 2 to times 2, you get 4, and then you get minus cos 2x from 0 to pi. Add the limit. So we have minus cos 2 pi over 4, then minus cos 0 over 4. So cos 2 pi is 1, so that is minus 1 over 4. This is minus times minus to give you plus. Cos 0 is 1, so if you sum this up, you get 0. So therefore, what is the conclusion? So therefore we have sine x comma cos x. So this gives us 0. So therefore we conclude that what sine x and what cos x are orthogonal with okay, can just say with respect to the weight function r of x equals to 1 on that interval, which is 0 to pi. So this is true. All right, let's look at the second problem. Let's go back and look at the second problem. So the second problem says the set of function phi of n equals sine nx, is orthogonal. It forms an orthogonal system. So with respect to the function. So remember what orthogonal system says. It says we need to pick two distinct functions. Show that those two distinct functions are orthogonal. Once you can show that, then you've shown that that set of functions forms an orthogonal system. So let's go ahead to do that. All right, so we have solution to B. So what do we do now? We pick two distinct functions. Can just say let phi of n and phi of n be in what? Be in the set of functions that we're given, and then such that it is important you say that n is not equals to m. They must be distinct. So what is phi of n then? Phi of n will be sine nx, and phi of n will be equals to sine mx. So let's show that this function are orthogonal. So we do the weight function is given to be 1 with respect to the, so we show that it is orthogonal with respect to the weight function. Phi of n and phi of n. So this will obviously, let's just write the formula. The interval given to us was from, if you look at it again, it's from 0 to pi. So you have to remember your interval. The interval could be changed. So from 0 to pi, then we have phi of n, phi of m, arrow of x, dx. So if you put what phi of m is, so at this point, this one is sine nx, while this is sine mx. So this will now be equals to sine nx, then sine mx. The weight function is 1, so anything times 1, you get the same thing. So we need to evaluate this integral. So to evaluate this integral too, there is a trig property you must know, and that trig property says that the property is this. Trig properties cos n plus m x minus cos n minus m x, this will give you minus 2 sine n x cos sine mx. So if you make this sine nx sine ms subject to formula, you get sine nx sine mx equals to minus 1 over, because you have to divide by minus 1 over 2, into cos n plus m x minus cos n minus m x. If you decide to multiply, go through by minus, you will get, like, use minus to open the bracket, you get 1 over 2, then you minus times this, you get minus, this one become plus. You can start with the positive part, n minus mx, then this one is negative, so you can write cos n plus mx. So let's continue with our integration. So we have this guy, sine nx sine mx is equal to so now if you insert it 0 to pi, you get 1 over 2 cos n minus mx minus cos n plus mx. So all this will be dx. So if you bring out your 1 over 2 and then you take integral from 0 to pi, cos n minus this times x minus cos n plus mx dx. So what is this integration? So if you integrate cos, you get sine n minus mx over n minus m. So the general formula is, if I have sine n, if I have cos ax, I'm doing in respect to x, so this will just be sine ax over a. So you divide by the coefficient. Okay, you divide by the coefficient, then plus c. So for this is the coefficient n minus 1, like that. Then here you get sine 2 sine n plus m x over n plus m. So you take this integral from 0 to pi. So without wasting our time, so let's insert pi there. So you get sine n minus m pi over n minus m minus sine n plus m pi over n plus m. So you can put the 0, so you can say minus and sine, you can write what you have, n minus m at 0, which is actually 0, so there's no need to write it like that. But let's just write it just for formalities. So we have n plus m times 0 over n minus m. this is positive. All is being affected by the 1 over 2 outside. So now at this point, this is sine n minus m pi. You see, this is a constant. This is a constant. We don't care what it is. If you use a constant to times pi, you get something in terms of pi. So, and the thing is, sine pi is 0. You understand? Sine pi is 0. So if you use any constant to multiply that pi, it still gives you 0. It stays at 0. You can use your calculator, press, if you use sine pi, you get 0. Sine 2 pi, you get 0. Sine minus 4 pi, you still get 0. So whenever a constant times pi, you get 0. So this is 0, this is 0. So you just get 0 for these two. This is sine 0. You know, 0 times this, and sine 0 is still 0. So at the end of the day, you just get 0. So at the end of the day, this still gives you 1 over 2 times 0. The answer is 0. So therefore, this set of functions, which is equals to sine nx, is an orthogonal system. It's an orthogonal system with respect to the weight function r of s equals 1 on that interval provided for 0. So this is how you show that functions are orthogonal. Thank you very much for your time. See you in the next video. Make sure you subscribe. See you in the next video.